All right, today we're going to work on difference of two squares, and we're going to do 4 problems from difference of two squares section. I'm going to do 1, 4, 7, and 10. In number 1, when I see the difference of two squares, I'm going to notice that this is already in difference of two squares form, meaning this is a squared minus b squared. A, in this case, would be x, and x would be squared. And b squared, well, 81 can be rewritten as 9 squared. So our b is 9. So x is our a, and 9 is our b. And so remember, when we have things written as a squared minus b squared, or the difference of two squares, you can rewrite them as the sum of a and b times the quantity of the difference of a and b. And so I can rewrite this as x plus 9 times the quantity of x minus 9. It also works out because if I were to multiply 9 times negative 9, I get a negative 81. But if I were to add them together, this is just like our factoring. If I were to add them together, then I would get 0. And as you can see, there is no b here, there is no middle term, and so I get 0 when I add my two factors together. Let's take a look at number 4. Number 4 is a little tricky because if you remember from the last lesson, the first step of factoring is to factor out your GCF. And so I'm going to look for the GCF in these two numbers. And so I'm going to know that they both are even numbers, so they both have a factor of 2. They also both have a factor of 4. 4 times 25 is 100. 4 times 9 is 36. This has a factor of 5, this does not. This has a factor of 6, this does not. And you can keep going. I think 4 is the highest we'll go, and they don't share anything else in common, so I'll take a 4 out. Once I do that, this leaves me with a 9x squared, and this leaves me with a 25y squared. A lot of people might tell you that you don't have to factor out the 4 first. However, I'm grading on whether you can factor completely. That means your 4 would need to be on the outside. This is how you factor completely. So another thing we would need to do here is then realize that this is the difference of two squares. Here's your difference. Here are your two squares. 9 is a perfect square and x squared is a perfect square. 25 is a perfect square and y squared is a perfect square. So you can rewrite that saying as such that this is 4 times 3x squared, which will give you 9x squared here because you square the 3 and you square the x, minus 5y squared. 5 squared is 25, y squared is y squared. And now I can rewrite this using the difference of two squares. So I have my 4 on the outside, then this is going to be a plus b, and this is going to be a minus b. I have 3x plus 5y times the quantity of 3x minus 5y. And that's factored completely using the difference of two squares. Let's look at this one. And looking at it, I'm looking at that 225. It's always good to know your perfect squares. And so I know that the square of 15 is 225. So I know that this is in fact a perfect square. This is a perfect square. This is your difference. And this is a perfect square. So this is the difference of two squares. And so I can rewrite this as 15 times c, and then that whole thing is squared, which will give me, if I square the 15, I get 225. If I square the c, I get c squared, minus a squared. So if I rewrite that as the difference of two squares, a plus b times a minus b, I get 15c as my a, plus a as my b here. And the other side would be 15c minus a. And you're done. Let's do number 10. Number 10 is a little tricky, and so I wanted to go over it. In number 10, I noticed that my 81 It's negative, is on the left hand side. This is still the difference of two squares because this is a perfect square and this is a perfect square. However, I can use the commutative property to rewrite this so it looks just like the other problems. What I'm going to do is I'm going to bring this a to the fourth to the left hand side and keep it positive because it's already positive. I don't want to change that. I just want to change its location. However, when the leading term is positive, I don't write anything on the left hand side because it's implied that it's positive. I'm going to move this negative 81 to the right hand side. When I move that, I have to move the negative sign with it to keep it a negative 81. Now it looks like the difference of two squares. Let's write it so we can tell that it is. This would be a to the second because what we're doing is squaring a to the second to get a to the fourth. And we have 81, which is the same as 9 squared. You can always tell that this is a to the fourth by knowing your exponent rules. If I have a power raised to another power, then you multiply those two exponents, which would give me then a to the fourth. So now that I have this all worked out, I can factor using the difference of squares. This is my a, this is my b, so a squared minus 9, a squared plus 9. Hold on right here. We're not done. You can use the difference of two squares again right here because I have a squared minus 9. A squared is a perfect square and 9 is a perfect square. Always look for that second difference of two squares when you're doing problems like these because they may try to trip you up. Remember, our goal is to factor completely, and you might miss it if you're not looking for every single factoring opportunity. And so, I look here, I know I have the difference of two squares, and so I know that this will be, first of all, let's bring this down here. So this is going to be a squared plus 9. But over here, I'm going to have a plus 3, because the square root of 9 is 3, or 9 is 3 squared. A plus 3, and over here, a minus 3. So we use the difference of two squares right here as well. Let's do a recap. We moved this around so that it looked like our other problems, and difference of two squares. Then we found the difference of two squares to factor, and we had a squared minus 9 and a squared plus 9. But a squared minus 9 is the difference of two squares, so I could factor that out again, and that's how I got 3 factoring opportunities right there. All right, I need you to do all the problems in that section that are on this website, and have a good day.